Okay, for this part of the lesson, we're going to be actually doing one of the problems here. Now, this is a walkthrough problem. You were to actually attempt this on your own first before watching the solution. But now that you've done it, you can check your answers, or if this is you're having difficulty, then now you can follow along. So the first things you need to know are acceleration, change in speed over change in time, which is v2 minus v1, final speed minus initial speed divided by time. The average speed can be found by finding the initial speed plus the final speed and dividing by 2. And then if you know the average speed, you can then, or you know the distance and the time, you can actually figure out what the average speed is. So these three equations are what's necessary to simply find distances during uniform accelerated motion. That's accelerated motion where the acceleration is constant, meaning that it's not changing, it's not jerking around, it's not changing the acceleration. So it says Malcolm is riding a crazy camel and is accelerating at 15 meters per second per second. So there's one piece of information. That sounds like, since it's a change in speed, or it's a speed over time, change in speed over time, that's an acceleration. Their initial speed was 10 meters per second. Well, we know that's a v1. And its final speed was 135. So that's our v2. So things that we know. We know the acceleration is 15 meters per second per second. We know that v1 is 10 meters per second. And we know that v2 is equal to 135 meters per second. And it asks us to calculate the time required to do that. These are the four variables. Now clearly, it's starting at 10, ending at 135. So how many 15 meter per second increases are there to go from 10 to 135? I mean, just thinking about it, you'd be like, well, 135 and 10, that's 125 meters per second change. And how many times does 15 go into 225? And you would see, you would get an answer, or sorry, 125. And you would get a solution for the amount of time in seconds. So writing this out, we know acceleration is v2 minus v1 over delta t. v2 is 135. Notice the brackets I'm including here, minus 10 divided by divided by the time, which we don't have. So we know the acceleration is 15 meters per second. Like this. So we could have rearranged the formula right off the bat. I'm just showing you a slightly different way to do this. So if we're trying to find the time, we know that all we would need to do is take multiply the time up to the top and divide by the 15. So 135 minus 10 is 125 divided by 15. So the time is approximately 8.3 meters, 8.3 seconds. Like so. Okay. It takes about 8.3 seconds to do that. Calculate the average speed. Alright. The average speed that they were traveling at. Well, we know v1 was 10 meters per second. We know v2 was 135 meters per second. We know that the time they were accelerating for was 8.333 seconds. And that's really all we need to find, well, we don't even need the time actually, because if we're trying to find the VAV, we don't even need that information, because the average velocity is v1 plus v2 divided by 2. We could have used delta d over delta t, but the problem is that we don't know the distance that was traveled, so we can't use this right now. v1 is 10. Notice I'm putting the brackets. So the average speed is approximately 145 divided by 2, so that's 72.5 meters per second. Okay. Using the average speed, calculate how far they traveled in this time. Well, we know the average speed is 72.5 meters per second. We know the time that they traveled for was 8.333 seconds, and we know that the distance is unknown. So the average speed, distance over time, rearranging for distance, was the average speed times the time. And you can see it's pretty straightforward. Therefore, the distance that they would have traveled is 72.5 times 72.5 times 8.3333, about 604 meters in that time. You could have also bypassed all of this. These two steps you could have done together by just writing that v1 plus v2 divided by 2 equals delta d over delta t. So you could have actually combined step B and C by saying that the distance traveled is v1 plus v2 over 2 times delta t, like so. If you really want to get fancy, you could have even said, you could have combined steps A, B, and C together. So this is step B and C. You could have done A, B, and C together. Where delta t from previously was delta V over A. And delta V is just V2 minus V1. So you could have actually combined it all into one little simple equation if you really wanted to. But you can do this three-step process, the A, B, C, to get the same solution. Or you can try and combine the equations together into a fancy little equation, and therefore then you've basically done A, B, and C all together. Alright, the last part of this question. If Super Turtle then came to a screeching stop in 4 seconds, calculate the acceleration they would experience. Alright, so V1, at this point, Super Turtle is they're traveling at a final speed of 135 meters per second. Don't make the mistake of putting the average speed here. This is the initial speed V1 for this part of the trip. This is when they're at that maximum speed. So if you want to look at this graphically, they started at 10 and they accelerated for 8 seconds at a pretty big rate at 15 meters per second. So at about 8 seconds, they were going at 135 from 10. And then what they're going to do is they're going to, in 4 seconds, so 10, so at the 12-second mark, after 4 seconds, they're going to come to an abrupt stop. So this is going to be a negative acceleration. And it's going to be pretty steep because they're going to come from 135 down to 0 really, really quickly. So, as I just stated, the final speed, because they're coming to a screeching stop, would be 0 meters per second. The acceleration, we don't know. The time interval in which they come to a stop is 4 seconds. So, acceleration is V2 minus V1 delta V over delta T. V2 is 0 minus 135 divided by 4. And we see that our acceleration is going to be approximately negative 33.8 meters per second, slowing down every second. That's a very, very fast acceleration. That was a hydrogen balloon. All right, on the back, you're going to try to do the backside by yourself. So the car is moving from 20 meters per second, accelerates at a rate of 8 meters per second for 7 seconds. Calculate the final speed, calculate the average speed, calculate the distance. If you wish, you can try and do the just do all the equations together, or show each step individually. So that's your task. The solution will be at the front of the room waiting for you.